can have the most powerful AI model in the world running perfectly on your local machine, but if a non-technical customer cannot actually interact with it, you haven't built a product. You've just built a science experiment. Job postings for this specific role jumped 800% last year, with total compensation often starting at $200,000. To land these positions, you have to look past the common assumption that Python is the only language required for an AI career. This is the dual language mandate of the forward-deployed engineer. Python acts as the backend brain of the operation, while TypeScript serves as the front-end body. Mastering this connection allows you to move beyond isolated research, shipping complete solutions directly to clients. Let's look at a realistic scenario. Imagine stepping onto a factory floor. The client wants to use AI to track their supply chain, but their current system consists of decades of disorganized, siloed database records scattered across different internal servers. This is where Python excels. You use it to wire up a structured AI agent that connects those messy internal records to large foundational model APIs, like OpenAI or Anthropic. Inside this agent, Python handles the heavy lifting. You build retrieval-augmented generation pipelines to search those factory records, and you run evaluations to verify the accuracy of the model's outputs. But Python's direct output is just raw terminal text. A factory manager trying to make quick business decisions on the floor cannot use a scrolling block of code. The client requires a clean interface, a visual dashboard with clear buttons and readable charts that makes the AI's insights actionable. So how exactly do you trigger a backend Python script from a visual web page? You build the front end using TypeScript. Companies choose TypeScript because its type safety strictly defines how data behaves, preventing the errors that typically crash production-level environments. This reliability is why clients trust the tool. TypeScript ensures the dashboard remains stable when the factory manager clicks a button to request a new inventory report. To connect the two, you use REST APIs. This bridge acts as the secure plumbing between your TypeScript front-end and your Python backend. When the manager clicks Analyze Inventory on the dashboard, a secure request travels across this bridge, triggering the Python backend to execute its AI process. Python processes the messy factory data and sends a clean response back across the bridge to instantly populate the dashboard with organized charts. Mastering this API bridge allows you to take code off your local machine and embed it directly into a client's live business environment. This is the complete data flow, from the messy database, through the Python AI brain, across the API bridge, to the TypeScript body. The final step is wrapping this architecture in Docker and deploying it on AWS or GCP for live client access. The workload follows a specific breakdown. Python commands 2/3, covering APIs, RAG, and quality checks. TypeScript handles the final third for UI and dashboards. Wielding both turns a raw model into a finished product, driving FDE salaries to the top.